Hi, in this tutorial I will give an overview of OPC UA in Python. So here you see the contents of this tutorial. First a short introduction, then an overview of the software I'm going to use in addition to, of course, Python. I will use some demo OPC UA server in order to test the Python code, and also part of this tutorial I will create different Python scripts, both OPC UA Clients and OPC UA Server. So basically this tutorial will use the OPC UA protocol to send data between different devices or different programs. And OPC UA is a communication protocol, and OPC UA is mainly used for industrial purposes or industrial automation applications, and it's one of the most used protocols in the industry today. So OPC UA is maintained by the OPC Foundation, while Python is a widely used multi-purpose programming language and probably one of the most used programming languages today. Here you see a typical OPC UA example where we have different OPC UA clients and we have an OPC UA server. So in general we can have many OPC UA servers and many OPC UA clients, but typically we have one OPC UA server that is the heart of the system, and then we have different OPC UA clients distributed in a network, and these OPC UA clients, some of them are writing data to the OPC UA server, while others are reading data from the OPC UA server. So in this tutorial we will use different software and different OPC packages and different libraries for Python. And this tutorial will demonstrate OPC UA in Python with some basic code examples, and we will use the OPC UA Python package in this tutorial. We will also in this tutorial use different Python editors. We will use the Thonny Python Editor, and we also use the Spyder Python Editor. We will also use an OPC UA server, a demo OPC UA server called OPC UA Server Simulator. We will use this in the beginning in order to test our OPC UA client applications that we are going to create with Python. So when we are finished, we should have created different OPC UA clients and an OPC UA server using this Python package called OPC UA. Here you see an overview of the software that we are going to use. So we are going to use the Thonny Python Editor. You find it here and you can download and use it for free. We will use the Spyder Python Editor, which can be downloaded separately or part of this Anaconda Python distribution. And the Python package we are using, OPC UA, you can find more information about that package here. But basically you just install it using the pip command or the built-in features in the different Python editors. We will use this OPC UA Server Simulator as a demo OPC UA server when testing our OPC UA clients that we are going to create in Python. We will also use an OPC UA client called UA Expert in order to test the system and make sure that everything works as expected. So basically we will create 3 Python applications or Python scripts in this tutorial. We will start with an OPC UA write client, and then we will test that OPC UA write client with a demo OPC UA server, and then we will create an OPC UA read client that are reading the data that we are writing to the OPC UA server. And also when we have created those 2 OPC UA clients, one for writing and one for reading data, we will also create an OPC UA server in the Python programming language using this OPC UA Python package. So in order to install this OPC UA Python package, let's start with the Thonny editor. We just go to the in the tools and the manage packages, then we just search for OPC UA and then we find the package, and then just click on it, and then you just click on the install button, and then we are ready to use this OPC UA package in Python and within the Thonny editor. The same if you are using the Spyder and the Anaconda distribution. You can use this Anaconda prompt tool that comes with Anaconda. It looks like this. And then you basically just type pip install OPC UA in order to install this OPC UA Python package. So before we start creating these Python scripts or Python applications, it's good to have some OPC UA test or demo software that we can use in order to make sure that our Python applications works as expected. So then we will use this OPC UA simulation server from Integration Objects. This is a free OPC UA server that you can use. So you can use it for 48 hours for free. And after 48 hours, you basically just need to restart the server in order to continue to use it. Of course, you can also pay for it and then use it 24/7. So here you see the software, this OPC UA Server Simulator. So we will start using this OPC UA server and creating our OPC clients in the Python programming language. Also, the same company has an OPC UA client that you can use to test and demonstrate your applications. So here you see the OPC UA client from the same company, this Integration Objects. Also handy to use when testing your Python applications. Another handy OPC UA client that you can use is the UA Expert from Unified Automation. That's another OPC UA client that is handy to use when creating and demonstrating or testing your Python applications. So you can download it for free here and start using that OPC UA client as well. So here you see an image of this UA Expert OPC UA client from Unified Automation. Basically, you just connect to any kind of OPC UA server here, and then you will see the list of tags that are available on the server, and then you can either write data or read data from that specific tag. So then let's start creating some OPC UA clients examples using the Python programming language and this OPC UA Python package. So we start by creating some OPC UA clients. We will create one OPC UA client that are writing data and another that are reading data. And then we will use a demo OPC UA server in order to test our application. And we will use this OPC UA Server Simulator from Integration Objects in our examples. So basically, we will create an OPC UA write client, and then we will write or send data to this OPC UA server from Integration Objects, this OPC UA Server Simulator. Later, we will also create an OPC UA server in Python, but let's start with this demo server, because we know that this server is working fine, and then it's easier to verify that our Python code also works as expected. And then when the data are stored in the OPC UA server, we will create a second application, an OPC UA read client that are reading the same data that we are writing from this application. So here we see the basic code needed in order to create an OPC UA client write application using this OPC UA Python package. So the first thing we need to do is to import this library, OPC UA. And in our case, we only need to import the client part of it. And then we need to specify an URL and a node ID. This information are information from the OPC UA server that we need to specify. And then we need to create a client object and connect to the server, which is specified here in the URL. Then we can use this method that is part of this OPC UA Python package, get_node, in order to just create a node object. And then we can here basically just specify a value. In this case, I just hardcode the value 20. Here you can create a simulator or read real data from a sensor, a temperature sensor, or other types of sensors or equipment, but here, just for taste purpose, I just specify 20 as a value that we are going to write to the server, and then I specify or use this set underscore data underscore value method in order to write that specific value to the OPC UA server that we have specified here in the URL. After we are finished, we can disconnect from the server using the disconnect method. So this is for writing data to the OPC UA server. When we are going to read data from the OPC UA server, it's almost identical. We need to use or import this OPC UA package. We need to specify the URL and the node ID. We need to connect to the server. We need to create this object. And then instead of this set data value, for writing data, we are using get underscore value in order to read the specified node ID from the OPC UA server, and then we can just print it on the screen using the print command like this, and then finally we can disconnect from the server. So basically these are the two basic applications that we are starting with: an OPC UA client that are writing data to the OPC UA server, and then next an OPC UA client read that are reading the same value from the OPC UA server. So then we will have these applications up and running at the same time. So here we have the OPC UA Server Simulator up and running. Here we have the OPC write application that are writing to the server, and then we have this OPC UA read application up and running, and all these applications then are running. So then here we are writing a data that are stored in the server, and then after that we are reading the same data from the server. So let's go to the Thonny editor and see how this is working in real life. So now I have opened my Thonny Python editor. To save some time, I have already written the necessary code. So here I have specified the URL to this simulated server from integration objects. So let's start this server as well. So I just have installed it already, and then just type search and OPC UA, and then I find this OPC UA Server Simulator. Click just yes here, and then click OK here. And now this OPC UA Server Simulator are up and running, and here you see the server URL that I'm using here in my Python application. So here I specify the URL to that specific server, which is the same address that you find here on the server. Instead of my computer name, I'm just using localhost, and then this will work on all computers. And then this OPC UA server comes with some predefined tags that you can use, and one of those tags are just called tag 7. So the default tags here that comes with the server are just tag 1, 2, 3, 4, 5, 6, 7, etc. And then I connect to the server, and then just specify a value. In this case 22. I can write any kind of value here, and then I just use this set data value in order to write data to the server. So that's the write application, and here I have the read application that should be reading the same value. In this basic example, I'm not using any loop or anything. I just write this value once in this application, and here I just read that same value once and then disconnect from the server. So now let's just have these two applications like this, and then here I click on run on this write application, and basically I'm writing the value 22 to the OPC UA server, which is here, and then here in the second application I should now read the same value by just clicking this run button. And then you see I'm reading the same value, 22. I can change the value to 24, run this application, and then run the other application, and then you see I'm able to write and read a specific value to and from that OPC UA server that I have up and running here. I can also check with this UA Expert OPC UA client, so I just open that one as well. I have already installed it, so UA Expert, that's the another OPC UA client that you can use for test purpose and check that your applications are working as expected. So here you can basically just connect to a specific server. Then I can just use this URL for this server to connect to this server. Go here under Advanced, just type the endpoint URL, which is this one. I'll just paste it in and click OK. And now I'm connected to that server. Then I can, I just need to connect by right-clicking and connect, click OK here in order to connect to the server. And then you see the different tags that are on the server. As mentioned, you have tag 1, tag 2, 3, 4, etc. up till tag 19. In our Python script, I'm using this tag number 7, which you find here. So then I can just right click on it or double click. So let's summarize what we have done so far. We have created a simple OPC UA write client that are reading just a specific value, in this case 22 or 23, 24, whatever we specify here. Write it to this OPC UA server, which is a demo or test server that you can use to test our application. And then we have a second Python script that are reading the same value from this OPC UA server, as you see here. So this OPC UA read script are able to read the same value that we are specifying and writing here in the right application. Of course, there are lots of improvements that we can make to this two simple Python scripts. So basically there are lots of improvements that you can make. Most important is to write or add a while loop or whatever, so we are able to both write and read multiple values from and to the OPC UA server. You can add some arrow handling, etc. So there are lots of improvements to be made. Let's at least show how you can use a simple while loop in order to improve your application. So here you see the OPC UA client write application, where I have added a while loop, and then in each iteration in the while loop I'm writing a new value to the OPC UA server. I also used a try catch here, so when I'm clicking Ctrl+C, the program stops and disconnect from the OPC UA server. The same for the OPC UA client read example. I have added a while loop that goes forever, so while true, and also added a try here, a try catch in order to read value from the keyboard. So when I press Ctrl+C, the program stops and disconnects from the server. So let's run these two applications as well in our Thonny Python Editor. So now we are back in our programming environment. Here I have the Thonny Editor, here I have the OPC UA server, and now I'm opening two Thonny editors. Here I have one that are having this OPC UA write application. Here I have the other application, the OPC UA read. Since I'm using two Python editors running at the same time, these two can be running at the same time as well. So in order to make that happen, I go to Tools, click on Options, and then in the Thonny Options General, here you can deselect this choice, allow only single Thonny instances. So if you deselect this one, you can have two Thonny editors, two Thonny Python editors up and running at the same time. So let's just start this OPC UA write application here. And now you see I'm writing a value to the OPC UA server, and then you see I'm still connected to the OPC UA server here. I'm writing new values in each iteration of the while loop. So every 10 seconds there's a new iteration in the while loop, and then I write a new value to the OPC UA server. Then I can, at the same time, while this is running, also run this OPC UA read application. And then you see it's able to read the last value that I'm writing here to the OPC UA server. So every 10 seconds I'm writing a new value. So now it's the last value is 29. And then you see 29 is also read here from this OPC UA read application. And then you see here in the OPC UA Server Simulator, both the OPC UA client that are writing data are connected, and the second line here is the OPC UA read that are connected. So when I click, let's say here in this OPC UA read, if I click Control C here, then this application should stop. So here you see OPC UA client disconnected and program stops. And that's the message I'm just writing here using the print command. And then you see here in the OPC UA server, and only know one application is running, and that's this application. And if I do the same here, click Control C in order to stop the application. And then you see also here you got this OPC UA client disconnected and program stopped, and no OPC UA clients are now running, as you see here. So basically this is how you write two Python applications. Here you have one application that are writing data to the OPC UA server, and then you specify the URL to the OPC server here. You specify which tag you are going to, in this case, write to, and then you just use a while loop. Here I am just using a random generator that automatically generates a new value every 10 seconds between 20 and 30. So I'm just simulating a basic temperature simulator or some basic temperature sensor or something using this built-in random functionality in Python. And then I'm just writing this value to the server, and in the read application, which is almost identical, but here I'm just using this node get value in order to read that specific value and print it on the screen like this. So that's how you create two basic Python OPC UA clients application in Python. Here one for writing and the second one for reading. Of course you can have read and write in the same application if that's something you need. You can also, of course, write or read multiple tags just by specifying more tags here. And of course you can also use some event handling or something instead of a basic while loop, as I have done in these two basic examples. Of course, instead of using Python, using the Thonny editor, I can use any kind of Python editor. I can also run it from the command prompt in Windows. Different ways to do that. I can just type here a command and execute and do that twice. So I have one command prompt for writing and one for reading. A simpler way is just do that from the Thonny editor, so then you can just click here run and then select run current script in terminal, and then here you have this OPC UA write application is running. I can do the same for other one, OPC UA read application, and then the two applications are now running in the command prompt window in window. So here is the write application. The last value now is 24, and then you see I'm reading 24 here, and then a new value will be written every 10 seconds, now 25, and this new value 25 are now read by this other application. And then you see two Python applications or Python clients are now running and are connected to this OPC UA Server Simulator. And of course I can also use this Spyder editor, so let's open the Spyder Python Editor as well. Then I can have these two applications running in the Spyder, or I can have one application running in command prompt or in Thonny, so you have different options here. In order to run multiple instances of Spyder, you can more or less do the same here. So you need to go to Tools, and then you select Preferences, and in this Preferences window here under Application, you have this option here under Advanced Settings. Use a single instance, so if you deselect this one, you can run multiple versions of your Spyder editor. So now I'm having the OPC UA server here. I have the OPC UA write application here in my Thonny editor. Let's start it, and it's connecting and writing values to the server, as you see here. Then I have the Spyder editor here. Here is the OPC UA read script or application. Let's run that one. And then you see now two applications or clients are connected to the server. One here in Thonny and the other one here in my Spyder editor. And then you see it's able to read these values from the OPC UA server. So next, let's see how we can create an OPC UA server in Python as well. So now we are going to have three different applications. All three applications should be written in Python. So now we should also have an OPC UA server running in Python, and an OPC UA write client running in Python, and an OPC UA read client running in Python. So here you see a basic example of an OPC UA server written in Python. It's very simple, and of course you should add more functionality and add more features to this OPC UA server in order to use it for real purposes. That's just for demo here. So basically you use the same Python library, OPC UA, but here you import the server part of the library. Then you just define the server using server equals server, and then you specify a server URL for your OPC UA server. In this case, this is just your local IP address, and here you specify the port number, and then you just use the set endpoint method in order to set this URL for that specific server, and then you specify a name for your OPC UA server. I just name it OPC UA Python or whatever, and then I establish a namespace and register that one in the OPC UA namespace, and then you use different objects or methods that are part of this OPC UA Python library. So basically here you need to specify an object, or it's just basically a folder where you put your tags inside. So I specify a folder called sensors, and within that folder I create an OPC variable or an OPC tag. I just call it temperature. Of course here you can create whatever you like, and of course you can have multiple tags or multiple variables within that folder or namespace. Just to demonstrate, I'm just creating one OPC UA tag in this example, and then we have our two OPC UA clients that should now connect to that server. You can also, of course, improve the server. You can create a while loop like we did for the OPC UA clients applications. So here I have done the same. I just put this code and added or improved it by using a while loop, and I used a try catch in order to stop the server when I click this Ctrl+C button. So basically now we have 3 applications, one OPC UA server written in Python and 2 client applications, one for write and one for read, also written in Python. So let's test these 3 applications. So here I have my OPC UA server. Here in Thonny I have another Thonny editor up and running here. This is the OPC UA write client, and here in Spyder I have the OPC UA read application. So here let's run this server. Here I can just click here, run current script in the terminal. So then here in command prompt we are now running the server, and since now the current value is 0 because there are no clients that are writing values to this server. So let's start this OPC UA write client here in this Thonny editor. Just click the run button, and this one just write a random value between 20 and 30. I can also open this one here in a command window. So run current script here. Then you have 2 here, the server is running, and here you have the client running. And as you see, we of course get an error message here because in our write and read application I haven't changed the URL, so it's still trying to connect to this previous OPC UA server from integration object. So I need to change my URL to this new OPC UA server. So basically now I have copied the server address, which is the server running here, into this OPC UA write application, and now OPC server it's now the OPC UA server from Python. So this is the URL which I have defined here, and next I need to specify the node ID, and then we have specified a tag called temperature, but here you typically need to specify the node ID. So in order to find this node ID, I can use this other client, or this OPC UA expert client, used for test purposes and to test your application. Here I can start by connecting to this Python server that are running here, this OPC UA Python server. Click OK, and then just right click, connect, and then you see under object here I got these sensors and the temperature, and when I click on it, then you see this node ID here, which is NS equal to semicolon I equals to 2. So that's what I need to specify here under node ID. So then I just replace this one from the previous server, and then NS equal to 2, S equals to 2, like this. So now let's run this application, and now you see we are able to connect to that server, and now hopefully we are up and running here. So let's try once more. I had a spelling mistake here. Instead of I was typing S here, so S equals to 2. It should be I equals to 2 here in the node ID. So now I have 3 Python scripts here. This is the Python script for the OPC UA server. Here is the Python script for the OPC UA write application. And here is the Python script for the OPC UA read application. So these 3, you can run it all in the Thonny editor like this, having it in 3 different windows, or you can have it in the Spyder editor. You can have one in Thonny, another in Spyder editor. You can have one in the command window, etc. And you can of course run all these 3 applications on 3 different computers. That's how it should be in real life. You should have these 3 applications running on 3 different computers. But for test purpose, I just have all 3 on the same computer. So now I have the server here, the server URL, and then we specify these sensors and temperature, which has this node ID here on the write client, and the same here on the read client. So then just start And then of course you need to make sure that you start by running the server before the clients. If you run the clients before the server, they are not able to connect to the server because it hasn't started yet. So always start the server first, and then now the server is up and running, current value is 0. Then I'm going to my write application. I run this application as well, writing a value 22, and then you see it reads that same value on the server, or storing it on the server. And then finally I have this OPC UA read application. Let's run this one as well. And now all 3 applications are running. Here is the writing 21. The value is 21, is stored on the server and read by this OPC UA read client. So now all these 3 applications are running in the same time, and of course in order to stop them I need to stop the clients before I can stop the server. So then I just click Ctrl C here on the different clients in order to stop. So now this OPC UA read client has been disconnected and program stops. I do the same for this write application. I stop it. Now this is stopped, and now only the server is running, and of course now I can restart the clients, but I also stop the server clicking the Ctrl C button, and now also the server are stopped. So basically this is how you create a basic OPC UA server using this OPC UA Python package. Here you use the import server part for the clients. You use the import client part here for this write client, and same for the read client. And then you just specify the name of the server using the URL and the node ID. In this case I'm just writing and reading one specific node, but here on the server you can create multiple nodes or multiple variables by just specifying more nodes or more variables here. So then you just copy this one in order to add more nodes or variables on the OPC UA server. So that should be all for now. So now we have created 3 different Python applications, 1 OPC UA server and 2 OPC UA clients, one for writing to the server and another one that are reading from the same server. So that should be all, and good luck with your Python applications and using OPC UA. Thank you and goodbye.